Many of us are not interested to write the notes in our classroom. So I would like to give a deep descriptive notes about Boran family in now. Here we can have a Boran family, and the elements in the Boran family are boron, aluminum, gallium, indium and tellurium, and their atomic numbers are 5, 13, 31, 49 and 81. Their general electronic configuration is NH2 NP1, and number of eliminating shells are 2 electrons in boron is 2 electrons, in aluminum is 3 electrons. The number of, and this is the notes descriptive, and boron isotopes, and we can have here boron isotopes and borax and carnallite in ore forms. And then when we go for aluminum is the third most abundant element in earth crust, and its oxidation state is +3 well known, and it's abundant in nature in the form of bauxite, cyanide. And atomic size increases down the group from boron to aluminum. Highly becomes greater spinning effect 2p in electrons in aluminum, and aluminum gallium as slightly increases becomes poor shielding effect of 3d in gallium. And here we have the graph about nuclear charge. Okay, next when further goes to ionic radius, their oxidation state is +1 and +3, and IP values IP1, and here we can have the graphs of IP1, IP2, IP3, and then we can have here graph for density, and then for electronegativity too, and then for boiling point and melting point. Here is zero, and electron potential value. Here we can have a relation. Reducing nature is inversely proportional to SRP value. This is reducing nature. Next SOP value and EA. And powerful reducing agent is aluminum, and least is tellurium. Oxidation state is +1 and +3, and tellurium occurs. And here from here there are chemical properties, reaction with air and nitrogen. Here there are the reactions with nitrogen. Tellurium does not react with N2 gas. Next, reactions with water. All these are reactions with water and reaction with acids and base. Boron does not react with a dilute HCl and concentric H2SO. This is the main point. And here we can form a boric acid H3BO3, which is important. We come further. Reaction with halogens. Leaves acid odors. And we have here structure dimer, and these are all bond angles. And here we can have the compounds of boron, that is borax, Na2B4O10.10H2O, and in which there are different hybridization and different structures that are trigonal bipyramidal sp3 and sp2, tetrahedral and trigonal bipyramidal. And here the borax is splitted and it forms a glassy mass. And when the borax is detached, which exhibits the color with the different elements with the chromium, yellow, red, manganese, violet, cobalt, blue, nickel, brown, copper, green. Borax detached used to identify D block elements. And here we have orthoboric acid H3BO3. When borax heated with 5 moles of water and 2 moles of HCl, it forms orthoboric acid plus 2 moles of NaCl, and this is the bicrystalline. And here we can have anhydrides and their structures, diboron. And here the reactions of B2H6, that is diboron. You can have a deep descriptive about the reactions. Okay, next when we go, here we have benzene-like structure that is known as B3N3H6 structure. And structure of diboran. And deep descriptive about the structure here, and this is the structure, this is a deep descriptive about that, and here we can have